Okay, now let me bring up some of the slides. What I want to talk about just a little bit is variables. Just want to give you kind of an introduction to variables. I'll put this in slideshow. So what they have right now is primitive data types. There are 8 primitive data types that are built into Java. Byte, short, int, long, as you see there, float, double, boolean, character. I just want to go over a few of those. So a byte contains enough room, 1 byte, 8 bits, to write an integer from -28 to positive 127. That's the only size number you can get. If you wanted to go above, say 127, you couldn't use a byte. Byte can only store that much information in it. Short, which are 2 bytes, 16 bits, can go from -32,768 to +32,767. Int, which is what we're going to use most of the time when we're talking about integers, uses 4 bytes or 32 bits. And you can see the range that it can go there. So if you look at all these primitives, the biggest difference is whether they can be positive or negative and how much memory they're going to take. An integer takes 4 bytes, long takes 8 bytes, a floating point, which is basically has a decimal point in it, takes 4 bytes, and a double, again, has a decimal point. We can have fractions of a number, can go 8 bytes. So when we declare a variable, we first declare the type, like byte, short, int, whatever, and we give it a name. The name can be anything we want, as long as it's not one of the keywords. Keywords you can find in your book. Keywords are special words that Java uses, which means specific things. And what I would recommend is that you use words that mean something. Don't just use X, Y, I, J. They don't mean anything. If you look at the examples here, inches, that means something. I'm measuring something, or I'm getting something in inches. Month, I'm doing something with calendars or dates. Speed, same thing. These mean something. So use words that mean something. And again, look at how, like here we have timestamp. The general practice is you take 2 words, you put them together. There's no spaces in variable names. The first word is lowercase, and all the preceding words are uppercase. So here, timestamp, T is lowercase, S is uppercase. Sales commission, S is lowercase, C is uppercase, and that's kind of the standard way of writing variable names. Again, byte, short, int, long are all integers. They cannot have anything to the right of a decimal point. They hold whole numbers, and they show some examples: 5, 10, 23, 89. So again, no decimal points. And then we have floats and doubles, and they can take decimal points. Like here you see 1.7 minus 45.316. They can take decimal points. They're called floating point literals. And again, just kind of look at 29.75, 1.76. These are all double data types. And here we have like number equals 23.5. And why is that an error? Because we said it was a float, and that's a double. To do a float, we have to say number equals 23.5 F. F means it's going to be a float, and then it will work. If you don't put an F there, it takes it as a double, and I can't make a number, which is I identify as a float, into a double. So just remember, most of the time we're going to be using doubles. So at the first one, instead of saying float number, if I said double number, that would work. But anytime I use float, I have to put the F with the number to identify it as a float. Again, just one thing to show here, you don't put punctuation. I can't put a comma in between 1,200, the 1 and the 2, or the dollar sign. I have to put it just as it is, 1257.00. And Boolean values only take true and false. They can't be anything else. So I either set it whatever variable name equals true, whatever variable name equals false, one or the other. Can't be anything else. Character types. Character literals are enclosed in single quotes. As you can see, the A and the Z are single quotes. The 1, the \n, which means a new line character, are all characters. Even though there's 2 there, it only takes it as 1. They're not string literals. Strings are in double quotes. Characters are in single quotes. And what we use is the ASCII character set. If you look up on the internet, you can see the ASCII character set. It's 256 characters. It's actually the beginning of what's called Unicode. Everything on your keyboard can be represented with the ASCII character set or the first 256 characters of Unicode. Unicode is worldwide, which means any keyboard anywhere in the world, there's a code for it. And if you look under, say for example, A, you'll see what the ASCII or Unicode character is for an A. Offhand, I can't remember what it is, but it is something like 65 or something like that. And capital A is different than small a. So when you do characters, what is being stored in memory is the ASCII equivalent of, say, like an A, things like that. Oh, there it is, 65. Capital A is 65. And if you're taking 117, you might have already seen the binary. We're storing it into 2 bytes, 0, 0, and 65. And if you look here, you can see 1 is 0, 0, 0, 0, 0, 1 is 65 in binary. That's what's actually stored in memory. If I did a B, it'd be 1, 0, 0, 0, 0, 1, 1. So characters are stored in memory as binary numbers. So again, a character is a single quote, and I can store it as a binary number. And the decimal values are 65 and 66 in Unicode or ASCII for capital A and capital B. So one other thing I just want to talk about is the assignment operator, which is the equal sign. What happens when I have an assignment operator, what is ever on the left-hand side is stored in the variable name on the right-hand side. So if we look here, 2 is stored into months. 28 is stored into days. You can't say 2 equals months or 28 equals days. That's wrong. And you think about months or days, when I look at a variable, think about it like a box. I just stored this 2 in a box. 28 has another separate box. Think of a box with month on it. I stored the 2 in it. Think of the box with days on it. I stored a 28. And I can only store one thing. If I put later on month equals 4, the 2 is gone and only 4 is in there. Or if I say days equals 30, the 28 is gone and only 30 is in there. I can only store one thing at a time in this box. I can only store one thing at a time in memory. And so if I printed this out, it would say month 2 has, this would say 28 days. And that's what we print out on the screen. Variables have to be declared before they're used. Now you don't see, well, you see right here, integer, month, comma, days. I can put them on the same line, semicolon. What this is basically saying is month and days are integers. I declared them. I told the compiler before it starts, I'm going to need some memory. I'm going to need some memory for months. I'm going to need some memory for days. They're going to be integers. That's 4 bytes. Remember that. Store it somewhere. And so when I say month equals 2, it stores it in memory somewhere. Don't know where. Don't care. I just called it months. Days equals 28. I stored it somewhere else. It's equal to 28. Again, I can only store one number at a time. If I change month to 3 and days to, let's see, 3 is March 31, the 2 and the 28 are gone. So if I did something, can I do that? Let's see. I can't do it. Anyway, I can only store one thing at a time. So once I declare them, I can initialize them, and then I can use them. And here it is. This is month. Notice it's not in quotes, so it's not going to be printed out. This is in double quotes. It's going to be printed out exactly as it is. Month, space. Then I'm going to use the variable. What's it? Oh, that equals 2. Boom. Put 2 in there. Month, 2. Double quotes again. Has. And space on both sides. Up, no double quotes in here. It's a variable. What's it? Oh, days. Boom. Put 28 in there. Days. So, and again, variables can be declared and initialized on the same line. I don't have to do 2 separate lines. I could have said integer month equals 2, days equals 28. That's legal. No problem with it, and it'll do the same exact thing. So, that's about all I want to talk about variables. Any questions? Send me an email.